Okay, question 46, x equals at, y equals bt squared. So dx dt equals a, dy dt equals 2bt. Okay, b and a are constants, yeah, as it says in the question. So dt dx then is this constant, so it'll be reciprocal of it, 1 over a. dy dx then will be this times this. Okay, 2bt over a, and that will give you then the gradient. Okay, so it says and show that the equation of the tangent at the point P, so you're going to do y minus y1, which is b p squared, equals then this 2b little p then, yeah, over a x minus then a little p. Take the a up, ay minus ab p squared equals 2bpx minus 2abp squared. Okay, now you should take everything over to the right hand side and you should get out what they want then, ab p squared plus ay minus 2b, I'm going off the screen here now, 2bpx equals 0. Okay, so we've got exactly what we're looking for. Now it says then part B that the point D has coordinates a, 6b, show that there is no point P on C such that the tangent to C at the point P passes through D. Okay, so it's quite tongue twisting, isn't it, here? And you wonder what on earth is going on. Well, this is the equation of the tangent, okay? And it says that this point D, which is a6b, now it's saying show that there is no point P on the curve such that the tangent to C at P, so basically this, passes through D. Okay, that's what they're saying. So basically show that this tangent won't go through that. If you read that question, okay, if you really stare at it and read at it and think about it, they're saying, look, show that this won't go through here. Now this represents any tangent really, doesn't it? Any tangent to the curve at any general point P where the parameter is little p, and they're just saying, look, there's no point where basically these tangent will go through this. So what we do is we assume the opposite. Okay, we assume, let's just assume the opposite. Let's assume that a6b does go through tangent, okay, or the tangent goes through this point rather, right? But you get where I'm coming from, yeah? Tangent goes through this point. Let's assume the tangent goes through this point. Okay, so then what we'll do then is to say, well, if this is the case, a6b will satisfy the tangent equation. So we just sub it in. Okay, so you've got abp squared plus ay, no, y is 6b, minus 4, no, sorry, that's 2, isn't it? Minus 2 bpx, which is also a, equals 0. Now, let's tidy this up again. abp squared plus 6ab minus 2abp equals 0. So we can cancel the ab's, okay, because ab goes into all of them. So we've got p squared minus 2p plus 6 equals 0. Okay, that's what we've got. And then we'd be expected then to be able to solve this, okay, to be able to find the value for p. So this is true, but possibly we're not able to solve this, okay? That could be the case. Maybe this is impossible to solve. Maybe there's no solutions. There's no solutions. That means then this statement up here is wrong. In other words, the tangent won't go through this point. Now, I can show there's no solutions maybe by doing b squared minus 4ac, looking at the discriminant. So that would be minus 2 for b squared, minus 4 times a, which is 1, times c, which is 6. And if you work that out, indeed, that comes out to be minus 20. Okay, so no solutions implies assumption is false. Okay, in other words, that can't be true. So tangent will not go through 2a 6b.